Okay, so 2-4 is coordinate proofs using distance with quadrilaterals. Okay, so the whole idea of this section is going to be how can we use the slope, we're going to be talking about the slope, and the distance formula in a coordinate plane, and we're just going to use that information in order to decide if a quadrilateral is a rectangle, rhombus, square. I think that's it. Okay. Okay, so we kind of did this in the last section, but we're going to skip down to C here. Okay, so it says position a square. So a square, what do we know about a square?
4 right angles, 4 congruent sides.
True. Okay, 4 right angles, 4 congruent sides, and each of those sides happens to have a length of 2a. Draw on that axis a square. Any square. Anywhere with a length of 2a.
Oh my gosh. On which one? Method 1?
You get to pick, Matt. Whatever floats your boat.
Just square.
Just draw a square. Don't overthink it. You're confused already? Do you want me to draw an example?
Yes, please.
Okay, here's one way you could do it. I could say, here's my corner. So if I'm going to draw a square, I would go out to a length of 2a, go up to a length of 2a. How's that?
If you went out 2a and up 2a, it'd be a
Close.
square.
If I, yeah, right? Exactly. Agreed. See, we're on the same page. Okay, did anybody draw the square differently than I did?
No, I did.
Oh, of course, Matt, what did you do?
Alright.
Oh, did anybody do it differently?
Can you do it?
Oh, yeah, you could start anywhere. I mean, you can put a square anywhere. I could have started it way over here. Okay, as long as it's on my grid, it can really be anywhere. Okay. Alright, so moving to the next page, it asks us to write the coordinates of the vertices that we just found. Okay, so, yeah, each vertex, singular, and vertices, plural. Okay, so, whoa, don't do that. Okay, so what are the 4 vertices? If I draw it the way I have it. 0, 0. What was the next one?
0.
Okay, I'm going to say 2a, just because there's technically an a. 2a, 0. What'd you say? 0, 2a. What's the last one? 2a, 2a. Perfect. Okay, discussion. Discuss another way that you could have positioned the square. We just kind of talked about that. Okay, you could have centered the square at the origin and gone out instead of, if we centered it, we would go out how far on the
1A.
axis? 1a, right? And then still go up 2a, or if you centered the center of the square, you could have gone up and down. So there could have been a lot of different ways, right? Okay, so when writing a coordinate proof, why are variables used instead of numbers? What do you mean? Does anybody know why they use variables?
We don't know. Tell us.
Okay, the reason that they use variables is because if I use a variable, it includes any number that I could possibly plug into that number. Okay, so it's kind of like the blanket statement of this always works. Okay, as opposed to if I plug in a single number like 1, it might work or maybe it might not. I don't know if it works for every single number. Okay, so if I use a variable, I know it works for everything. that make sense?
It's okay.
Okay, variables. Okay. So we are going to do an example of proving that we have this quadrilateral, and it is specifically going to be a parallelogram. Okay, so in this it says to use slopes. Okay, so if you haven't figured it out yet, we're using slope to decide if things are what? Why would we use slopes if we're talking about parallelograms? Lines are parallel. Okay, so if we're using lines being parallel, what do we know about those kinds of slopes? They're the same. Okay, so all we're trying to do is figure out if they have the same slopes. Okay, so you can see in the work, I'm not going to go through this entirely, but the slope of AB, right here, is, 3, there it is. Okay, and then they go to BC, so that slope was 2/5. The slope of CD is 3, so what can we say about AB and CD? Parallel. Okay, and then this other side, AD, was 2/5. Okay, so we got two opposite sides, congruent, or excuse me, parallel, so therefore we've got a parallelogram. Alright, so they're going to run us through and do the same thing. What I'm going to do here is, because we're on the page and using points from something else, I'm going to write all the points on here. So A was 4, 4. B is 3, 1. C is -2, -1. And D is -1, 2. Okay, so we're just filling this out. Okay, so for the distance, A to B, what number goes in that little box? 3, right? 3 minus 4. Okay, if I go straight down from there, what goes in the box on the next one? -3. So we've got -1 squared plus -3 squared. So we got 1 plus 9, which is 10. Nailed it. Okay, now we're looking at BC. What's the first square from BC? So it starts with -2 minus 3. So remember, you're doing the difference of the x's, and then the difference of the y's, what goes in the next one? -1. Is everybody seeing where I'm getting those numbers from? What? Did somebody say no? No? Okay, so do you see that I'm looking at the ordered pairs? So for B, the x value is 3, y is 1. For C, the x value is -2, the y is -1. Okay, so on BC it says -2 minus. So if -2, if I'm finding -2, that's the C.
I didn't see the little
Oh, yeah, that's important. Yeah. Okay, so moving down, simplifying, what's the next box? -1 minus 1. -2. So if we square both those numbers, we get 25 plus 4. What's 25 plus 4? 29. Okay, from C to D. So C to D, find the 2 points. So we got -1 minus -2, the x's. And then what minus -1? 2. So you're looking at the dy. Okay, the next box, what's 2 plus 1? 3. If we add those together, we got 1 plus 9. 10. So anybody see something? Okay, so AB is equivalent to CD, so opposite sides are congruent. Okay, going to dA, so we got 4 minus, what? No. What's the x value of d? -1. And then for the y's, yep, -2. Okay, then we gotta simplify the inside. We get 4 plus 1. And 4 minus 2. And 25 plus 4. 29. So again, another set of opposite sides that are equal. So what's the statement that we can make? Compare the lengths, or the side lengths. The lengths of the opposite sides are congruent or equal, I would take. Congruent. By the actually they use opposite side criteria of a parallelogram. I would accept, I think that's a silly statement, definition of a parallelogram. Okay, those are facts about a parallelogram. We can conclude that ABCD is, in fact, a parallelogram. Sweet. Okay, so 2 ways to prove that we have a parallelogram. What are the 2 ways? Okay, so 2 sets of opposite congruent sides, or the other way you can prove a parallelogram is opposite slopes. 2 sets of opposite slopes are the same. Reflection, got it. Okay, so now we're going to do the same thing, but now not so set up. Okay, so we have to prove that ABCD is in fact a parallelogram. Okay, so what do we do first?
We gotta find this. AB.
Okay, so AB, so we're going to do distance. Okay, so from A to B, we'd have the change in x. So 3 minus 8. And then the change in x's, 2 minus 2 squared. Well, I just told them. So you get 5 squared, so 25 plus 0, right? 25 plus 0, so the square root of 25? 5. Is everybody okay with that mental math?
Yeah.
What? 5. Where, what?
Where it's like 2 minus 2.
To the second. That's a 2. 2 minus 2 squared. BC. Okay, so from B to C, we're going to do change in x's. So 8 minus 5 plus the change in y's. 2 minus 0. Can you do that in your head? So 8 minus 5 is 3. So we got 3 squared. 9. And then 9 plus 4. What's 9 plus 4? Square root of 13. Man, they don't give us very much space here. C to D. Change in x's. 5 minus 0 plus change in y's. 0 minus 0. Is everybody okay with plugging these into the distance formula? Following that piece? Okay, so I have 5 squared plus 0 squared. You have no idea what 5 squared is? 25. So yeah, 25. So the square root of 25 is 5. Okay, last one is from A to D. We're looking good so far. From A to D, so we got the change in x's. We got 3 minus 0 squared plus. Yep, 9. 2 minus 0 squared. So we got 9 plus 4. 9 plus 4. Square root of 13, which isn't breakable. Okay, so what do you think? Is this a parallelogram?
Yeah.
It is. Okay, so we could say A, B, C, D is a parallelogram because opposite sides are congruent. Okay, so just be aware, you guys, that you always need to make a statement at the end, like why you decided yes they are. Even though you are showing some algebra and showing work in your proof, you still need to make a statement at the end. Does that make sense? Okay, so prove that the diagonals of ABCD bisect each other. Okay, so how would I do that? So, go ahead. Okay, so let's talk about the diagonal of a parallelogram. Okay, so what do we know about diagonals of a parallelogram? That they bisect through the middle. Good word. So what do you think we're going to find? The midpoints. Nice. Okay, so we're finding midpoints of the diagonals. Okay, so which 2 points are diagonals from what to what? A to C. So let's start with A to C. So the midpoint of A, midpoint. Do you like my abbreviation? Midpoint of A, C. Okay, so I'll do this out. So it's you add the x's and divide by 2. So it'd be 3 plus 5 over 2. And then do the same with the y's. 2 plus 0 over 2. So yeah, I would agree 4, 1, right? Okay. So now we're going to do the same thing, find the midpoint of the other diagonal. Midpoint of BD. So we got 8 plus 0 over 2. And for the y, 2 plus 0 over 2. Anybody else find that the midpoints are exactly the same? Okay, so because they're exactly the same, they bisect each other. What's that? Because the midpoints are the same, the diagonals bisect each other. Doing good?
Yes.
Okay. So now we're going to move in more specifically. Okay, so what are our special parallelograms? What are they going to talk about? Rectangles. What else? Squares. And they're going to talk about rhombuses. Yep. So those are the 3 things. So what do we know about a rectangle? 90 degrees all 4, so perpendicular angles, right? Okay, opposite sides are equal. 2 sets. Okay, what about square? We talked about a square. All sides are the same. Right angles. What about a rhombus? Ooh, and what specifically about that intersection? The diagonals intersect exactly at a 90. Yeah, so a rhombus, they bisect at a perpendicular angle.
Have two congruent sides.
Yeah, 4. No, rhombus is 4. Yeah, so it's like a square that gets squished. Like a square that got squished. Like if you've never seen, what did you say?
Isn't a kite
Well, a kite can have 2 short legs and 2 long legs. A rhombus is technically a kite, but a rhombus has 4 sides that are all the same. But it's like a square. Imagine a square that you stepped on and got flat. Like a diamond. Yeah, diamond. There you go. Good word. Diamond. Okay, here we go. So, we've got a rectangle here, and we're going to find the opposite sides are congruent, which they do here up in this example. Okay, so those 2 are congruent. Okay, they did that for us. That's nice of them. And then they're going to say, well, it also has to be a parallelogram, right? So they talk about the slopes. So opposite slopes must be the same. Okay, so we'll fill the boxes in real quick. So QR is 1/2. So RS, so I'm looking right here and here, is what minus what? So Y2 minus, what's that? Do the Y's first. You do the X's. Yeah, so I would do Y's, that's by definition. Rise over run is slope. Rise is up. Okay, so we can do 0 minus 4, and then do -4 minus -2. Or you can go the other way. You can do 4 minus 0 and -2 minus -4. Both of those will work. Okay, so you should get -4 over -2, which simplifies to 2. Okay, then we go to ST. S and T, do you see S and T? S, T, here's T, S and T. So what's the Y's? Sure, 1 minus 4. So if I start with 1, what's the X? 4 minus -2. So I have 4, or 1 minus 4 on the top is -3, and then I have 4 plus 2. So that reduces to -1/2. I'm seeing a trend here. The last one, T to Q. So we're looking at T and then the first point Q. What's the change in Y's? 1 minus -3. 4 minus 2. So we got 1 plus 3 over 2. Okay, so why would they do this? Why would we find slopes? What's the whole point of this? Okay, so number 1, we can say we definitely have a parallelogram, right? At this point, we can look at the slopes and say I have 2 sets of slopes that are the same, so we have at least a parallelogram. And now we can multiply adjacent sides and see if they equal -1 to see if they're perpendicular. Okay, so QR slope is -1/2, and RS is 2, so that equals -1. Okay, so can I go through this fast? 2, -1/2, -1. ST, -1/2, QT. Hopefully you can see that we're getting to the same spot. Okay, so all of the angles are right. So what can we conclude? All the adjacent sides are what? Perpendicular. Adjacent means next to. So the quadrilateral is a rectangle. Nice. Okay, what would be different if this was explain how to prove that it is not a square? So what would make a quadrilateral not a square? Angles, and so you can do it either angles or sides, right? So you can say any angle not 90 degrees or any side not equal to the others. Does that make sense? So you can talk about it either way. You can do it with the angles or with the sides. Last page, guys. We're cruising. All right, so last one is rhombus. Okay, so ooh, there's a pretty rhombus. Now you can visualize it. No, it's not. Well, it is a kite, yeah. But a kite could also have two sides that were longer. You know what I mean? Like this. Right? That's a kite. But a rhombus is technically a kite. Two sets of congruent sides. Nope. For a kite. Yes. Yeah. So rhombuses and kites are both parallelograms. Okay, so we're going to prove that this is a rhombus. Are you ready? So what's our plan of action here? What do we have to prove in order for this to be a rhombus?
The slope of WY is perpendicular.
Wait, say that again. Wait, hold on. Finish your thought and then I'll go to that one. What did you say?
The slope of WY is perpendicular to XZ.
Ooh. Okay, that's going to prove, yep. Did everybody hear that? Because that's a really quick and easy way to find stuff about a rhombus. So if the diagonals are perpendicular, what else? Opposite sides of parallel. Okay, what else? What do we also have to find? True. Well, we don't know. We're not going to go there because we're not finding actual value of angles. Two sets of parallel lines.
And they're all the same distance.
And all the same. All the sides are the same side. There we go. So we need to prove that all four sides are the same length. Let's start with that one. Yeah, we need to prove lengths. All right, so we're going to do distance formula to find the lengths of all four sides. So I'm going to start with x, wx. So I do the change in x's, 0 minus 4, plus the change in y's, 0 minus 3 squared. Okay, so in our scenario, we have 4 squared is 16, 16 plus 9, 16 plus 9. 25, right? 25, we should technically say the square root of 25 is 5. Next one, xy. Okay, so change in x's, 4 minus 9, plus change in y's, 3 minus 3. So I get 5 squared, 25 squared, 25 is 5. YZ. Change in y's, 9 minus 5 squared, plus 3 minus 0. So 16 plus 9. Bet we could make an educated guess, huh? WZ is the last one. 5 minus 0. Oops. 0. So 5 squared, square root is 5. So definitely a rhombus. Okay, and that's really all I have to say. Because if I prove that, that's as far as I have to go.
what if we just have the numbers?
That is proving it's a rhombus. That's all.
It's automatic.
Yep, because by definition, a rhombus just has four sides that are the same.
So squares are wrong. You won't do anything.
Nope, not on this one. I wouldn't.
So
You
squares
could.
would be wrong, because like the midpoint won't be the same. So the angle.
The midpoint.
Actually,
Yeah, I wouldn't go further than you have to go.
So can a square be a
the
rhombus?
y is
Yep.
But a rhombus can't be a square.
Kind of like how a rectangle, the square can be a rectangle.
Right. All sides are congruent. So W, X, Y, Z, a rhombus. Okay, so question 8, so I'm kind of bleeding over. The diagonals are perpendicular. So all I have to do is prove that the diagonals are perpendicular on this. So how would I do that? So you have to find the slopes, right? So what diagonal should I start with? XZ. So I'm going to say the slope of XZ. So notice how I'm like using slightly different notation. You don't want to just say XZ, otherwise I'm assuming that's a length. Use M representing slope. Okay. So if I go XZ, my change in Y's would be 3 minus 0 and 4 minus 5, right? So 3 over negative 1, which is negative 3. Did everybody follow that? Okay, so then if I do the opposite one, so that would be WY. WY. So my change in Y would be 3 minus 0. Whoa. And 9 minus 0. So 3 over 9 is 1/3. So how do I prove that these are perpendicular slopes? They are opposite reciprocals, or you can multiply them and get -1. So you'd say 2 equals -1. So XZ is perpendicular to YW. Okay, so this one is going to use the proof of, so the first one they say determine that it's a rectangle. Okay, so what is the proof that shows that this is a rectangle for this particular example?
It's not a rectangle. Or it is a rectangle.
It's proving that it is a rectangle.
Well, the angle. So, not 90.
Okay. Well, just by looking at that, but how would you prove it? But I mean, like, what are the steps that they chose to prove that it is technically not a rectangle? What did they do?
they proved that.
So they use AC. What's AC? AC.
Is a diagonal.
They're using diagonals. Okay, so they're using diagonals, and what are they showing? What are they showing?
That they equal 90 degrees.
No. Okay, so they're finding the length of AC and finding the length of D or BD. So they're using the lengths of the diagonals and proving that since they are not the same, then it is not a rectangle. Do you see that? So they're using diagonals to make that proof. Does that make sense? Okay, so by definition, the diagonals of a rectangle would have to be the same.
Oh, okay.
Okay. Okay, so then determine if ABCD is a rhombus. Okay, so what are they doing now? They're using what? The slopes. Okay, so now they're going to use slopes of what kind of lines? Diagonals. Okay, so they're saying, okay, well, the slopes of the diagonals, what do we know about slopes of the diagonals of a rhombus? They're perpendicular. Okay, so if the slopes of the diagonals are perpendicular, then we can conclude that it is a rhombus. Okay, so another way to prove that it is a rhombus. Okay, so we could have theoretically gone back on question 7 and done it that way instead. Okay. How do you guys feel about B? Would anybody be upset if I skip that part?
No.
Filling it in? Do you want me to fill it in and then it'll make everybody happy, or just skip it altogether?
Let's just skip it over there. Yeah, we're just done.
That would make you happy if you were just done. I could tell you look like you're falling
I
asleep.
think we're okay. Yeah, go back to close.
All right, well then this is what I'm going to do.
Alright.
This is your homework to do question 9 and question 10. Okay, so due tomorrow.
Do tomorrow.
Due tomorrow, yep.